many carbon atoms are present. Okay, so that is total number of carbon atoms minus 1 we have to do. So take simple example. The first example, how many carbon atoms are there? There are 2 carbon atoms. So 2 minus 1 it is not 2, minus 1 it is not 1. So one line you have to draw like this. Okay, you can draw horizontally, vertically, nobody will ask. But you have to draw one line. So one line means how many carbon atoms are here? 1 and 2. Is it? It is a bond line formula for CS3 single bond CS. Next, second example, CS3, CH2, CS3. How many carbon atoms are here? Total 3 carbon atoms are there. That's why T minus 1 is equal to 2 according to formula. So we have to draw 2 lines. One is here, here. So give the number 1, 2, 3. 1, 2, 3. Is it? Next, third example, CS3, CH2, CH2, CH3. How many carbon atoms are here? Total 4 carbon atoms are there. 4 minus 1, you have to draw only 3 lines. So just here 1, 2, next one it is what? 3. You have to draw 3 lines and you have to give the number 1, 2, 3 and 4. Understood? Yes. We'll go for next type of problems. How to represent the molecules. So these are the basic problems. Fourth one, CS3, CH, again what? CS3, second carbon it is having again CS3. So this problem little bit has changed. Here, first we have to see the longest chain, straight chain. In that straight chain, how many carbon atoms are there? Total 3 carbon atoms are there. So according to bond line formula, total number of carbon atoms in straight chain it is 3 minus 1. 3 minus 1 it is what? It is equal to 2. Is equal to what? 2. So you have to draw the first 2 lines. Draw 2 lines. 1, 2. Over 1, 2. Give the number 1, 2 and next 3. 1, 2 and is it? Next, one more thing is very important here. Second carbon it is having the methyl group. Second carbon is having what? Methyl group. How to represent that methyl group? Just draw one line. Just draw one line above the plane. That means what? There is a CS3 group. There is no condition that you have to draw above the only. You have to draw. If you want, you can draw below also, but you have to remove this. But you have to remove this one. There is no condition that you have to draw like this. But you have to draw in the form of what? Zigzag pattern. How to do zigzag like this? Understanding? Zigzag pattern. So here 1, 2 and 3. 1, 2, 3. Second carbon it is having what? Methyl. So that we have attached. Is it okay? Next, fifth problem. Next one is what? Fifth problem. That is CS3, CH, next CH, next what? CS3. Carbon is tetravalent. So what we will do? We'll attach some more molecules, Cl and Br. Cl and Br. Just see in straight chain how many carbons are there? Count the number of carbon atoms. 1, 2, 3, 4. Is it? 1, 2, 3, 4. In straight chain, there are 4 carbon atoms. So 4 means, what is the formula? Bond line is equal to total number of carbon atoms minus 1. So 4 minus 1. 4 minus 1 means how many lines you are going to have? You are going to have only 3 lines. So how to draw that 3 lines? Here, 1, 2, 3. Is it okay? One, two, three. Three lines are joined. Next, give the number. 1, 2, 3, 4. Give the number 1, 2, 3, and 4. One thing you should have in your mind that terminal end means what? It is a containing CS3 group. Containing what? CS3 group. And here also first carbon means what? It is also CS3 group. Where the line it changes, the path it changes, there is a CS3 group. And here also there is one CS3 group. This molecule we are representing in the form of what? Zigzag pattern. Only that much. Okay. So next, second carbon, what we are having? We are having the chlorine. So I'll chlorine. Okay, I'm going to draw one line and we should represent that chlorine molecule. Sir, here you are not represented that CS3, but here you are representing the halogens, that is chlorine. What is the reason? So reason is what? This CS3 means what? The terminal end always is containing CS3. The line is containing what? CS3. But here these are not a carbon atoms. These are substituent group. घर के पास जो रहता है ना, there are also chlorine as well as bromine that we have to represent. Okay, so here second carbon we are having the chlorine as well as third carbon. What we are having? We are having the bromine that we have to write like this. That we have to write like this. Understood? Everybody understood the representation of molecules, bond line, formula, very important for 1 mark. They are going to give any compound. Only you have to follow the rule. Bond line is equal to total number of carbon atoms minus 1. Is it okay? Have you copied? Okay, fine. So next, we'll go for next type of problems. Sixth one. Next one is what? Next sixth one. I put you different molecule. CH, double bond, CH, single bond, CH, again CS3, and here I'll give CS3, and here 1, 2, 3, 4, what? Balance. 1, 2, 3, 4. 1, 2, 3. Just represent CH2. Okay. Just see. First we have to see the straight chain. In straight chain, how many carbon atoms are there? Total number of carbon atoms. Total it is having 1, 2, 3, 4. 4 carbon atoms are there. So 4 minus 1. So it must have the 3 lines. Have the 3 lines. Next. 1, 2, 3. Or 1, 2, 3. Next, give the number. 1, 2, 3, 4. 1, 2, 3, 4. 4 carbon atoms are there. Next, give the number here also. Should not get confused. Okay. Next, just see. You have to give importance. First and second carbon. What is there? There is one double bond. Okay, there is one double bond. That double bond you have to represent. Okay. Okay, that double bond you have to represent like this. Next step. 1, 2, 3. Third carbon it is having one methyl group. Third carbon it is having what? One methyl group. Just draw one line here the point. Is it? So it is a representation of molecule by using bond line formula. Next, 7th one. CH triple bond C. Next again C. CH2. Next again CH. Cl. Br. Next again here CSC. Is it correct? Whatever I have written molecule correct. Just we have to see the valency of carbon atom. Carbon is having 4 bonds. 1, 2, 3. This one hydrogen is 1, 2, 3, 4. Okay. This carbon 2, 3, 4. Okay. What about this carbon atom? This here 1, 2, 3, 4. As well as it is having hydrogen. Remove this one. Remove this one. Just make a bond with CH3. And just we have to see how many carbon atoms are there in straight chain. So this is the straight chain. Is it? This one is not straight chain. In a straight chain, how many atoms are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Total 5 carbon atoms are there. So according to bond line, 5 minus 1. Total number of carbon atoms minus 1. So total number of carbon minus 1 means what? It must have the 4 lines. So you have to draw 4 lines like this. 1, 2, 3, 4. Is it? I have drawn 4 lines. Give the number 1, 2, 3, 4, 5. Is it? Next. First and second carbon atom it is having triple bond. How will you represent triple bond? Cl 1. Is it? First and second carbon it is having the triple bond. Next step, second and third single bond. Keep as it is. Third and fourth does not having it is also single bond. But fourth carbon atom it is having one Cl as well as bromine. So that Cl and here it is bromine. Next, fifth carbon atom that is CH3. Understood? Is it okay? Okay, fine. So I'm going to give 5 problems homework. Just try it in your home. Is it okay? Homework. Okay. 1, first one, second one, and one. This is two. 1, 2, 3, 4. Okay, fine. Third one. C. 1. Next C. CH, E, CST, and one more CST. Okay. Next one is CH2. What will do? Yes, you from the seven. Okay. 1, 2, 3, 4, 2, 3, 4, 5. What about this carbon atom? 1, 2, 3, 4. This 1, 2, 3, 4. Just remove this side. So carbon is from left. Four problems. Four. Last one. Fifth one. CH3, CH, Cl, Br, H3. Okay. Cl 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 4. Is it? So I have given 5 problems for the homework. So here I'll give some hints how to solve the problems also. So first we have to select the longest chain. The chain is having more number of carbon. So here first 1, 2, 3, 4. So 4 minus 1 is what? You must have the 3 lines. Must have the 3 lines. Next, here second problem. I think you are going to face the problem here. The second CH3, CH2, CH again CH3, CH2, CH3. How to solve this one? You have to select see the longest chain. Which one is longest chain? This one is the longest chain. Okay, this one is not longest chain. In that longest chain, how many carbon atoms are there? 1, 2, 3, 4, 5. So 5 minus 1. 5 minus 1 is must have the 4 lines. Must have the 4 lines. Give the number 1, 2, 3, 4, 5. Third carbon it is having the 1 metal. That we have to solve. Next, third example. So here also how many carbon atoms are there? 1, 2, 3, 4, 5. So 5 means 5 minus 1. It must have the 4 lines. Must have the 4 lines. But second and third as well as 1, 2, 3, 4, 5. First and second, it must have the double bond. Second and third, it must have the double. Is it? Next, fourth problem. 1, 2, 3, 4, 5. So total 5 carbon atoms are there. 5 means 5 minus 1 must have the 4 lines. Must have the 4 lines. First and second, there is no double bond. Second and third, it is having one double bond. As well as third, you have to represent methyl group. Fourth carbon atom 4 and 5, it is having one double bond. As well as fourth carbon atom, it is having one CH3 group. As well as fifth does not have any, is having only double bond, that you have to represent. Is it okay? Next, fifth problem. In case of fifth problem, how many carbon atoms are there? Just check. 1, 2, 3, 4, 5. So total 5 carbon atoms are there. It means 5 minus 1. So here 4 bond lines you have to draw. Next, give the number 1, 2, 3, 4, and 5. Second carbon, it is having CS3. Third carbon, it is having Cl. Fourth carbon is having Br. So these substitute these halogens you have to represent. This one you have to show in the form of what? Line. Is it okay? You have to solve in your home. I given 5 problems. Copied? Second one, sir, please explain second one once again. Okay, I'll explain. I'll explain that one. The second problem, it is a little bit different. How it is different? So instead of giving straight chain, I have extended that carbon chain down. Okay. CH3, CH2, CH, CH2, CH3. So you have to select the carbon chain which is having more number of carbon atoms. So if you select this one, we are having only 4 carbon atoms. I'm going to get what? Only 4 carbon atoms. Can draw, but actual rule what it is telling, you should select the chain which is having more number of carbon atoms. So that's why 1, 2, 3, 4, 5. Okay. So 5 means what? 5 minus 1 it is what? 4. So how many lines you have to draw? I'll show that also. 1, 2, 3, 4. Is it? So total 4 lines you have to draw. Give the number. 2, 3, 4, and 5. Next, carbon is having CS3. Just draw CS3 down there. Is it okay? Okay. Is it okay to everyone? Is it okay? Copied? Just copy that one fast. Second one already I have solved. You have to solve first, third, fourth, and fifth. Is it? So I'm going to rub this one. Next, right? I think classification of organic compounds. Let's study the right classification of organic compounds. Okay, classification of organic compounds. So I'm going to give the flow chart. So we'll afterwards we'll study one by one now. So that is organic compounds. Organic compounds. divided into mainly two types: open chain, as well as closed chain. Open chain as well as closed chain. Again, in case of closed chain, again there are two types. One is homolytic compounds, and this one heterolytic compounds, organic compounds. Next, in case of homolytic, again there are two types. That is alicyclic, another one aromatic, another one what? Aromatic. So the chain it is. So in organic chemistry, especially is the organic compounds, we are going to study mainly based on this chain only. That is first one, open chain, closed chain. Closed chain again classified as homolytic as well as prolytic organic compounds. Homolytic again it is classified as polycyclic as well as aromatic organic compounds. Just draw this flowchart. We'll discuss one by one. Copied. Open chain, closed chain, homolytic, heterolytic, alicyclic, and aromatic. Okay. Next. We'll discuss one by one. What do you mean by open chain? The carbon atom, they're having the straight chain, otherwise branched chain. When the chain, if it is having straight chain, as well as branched chain, we are going to call it as open chain only, because here open chain means what? They must have the straight chain as well as some compounds that are in the branched chain. So those are known as open chain. I'll give one example for straight chain. Already we have discussed CS3, CH2, again CH2, next again CS3. Okay, so it is an example for what? Straight chain. Next, what do you mean by branch chain? Your chain is there now. Write one more molecule. Add one more molecule. CS3, CH. Next again CH. Next again CS3. Okay. To that, if you draw one branch, CH2, again CH3. Okay. Here it is CH. So this is straight chain. This having one branch also. Those are what? Open. They are not closed anyway. Is it okay? So open chain means what? The chain which is having straight chain as well as branched chain. Those are known as open chain. Next, if we join this two carbon atoms, that we are going to call it as what? Closed chain. And we are going to call it as what? Closed chain. So here it is open now. So if you close like this, we are going to call it as what? Closed chain. In case of closed chain, I'll give an example for closed chain also. So how many carbon atoms are here? 1, 2, 4. That only I'll join that. So after joining, what will get? CH2. CH2. Next again here CH2. Here just join this. Okay, just join this one. Is a closed chain. Is what closed chain. Next one. That closed chain continuous. Here the cycle is what continuous. The bond it is continuous. But here somewhere that bond it has broken. Somewhere bond it has broken. So that's why it is straight chain as well as branch chain. We are going to call it as what open chain. But in case of the closed chain, the chain is what? It is continuous. It's moving in what? Continuous. So that's why we are going to call it as what? This one closed chain. Next, we are having classification of again closed chain into homolytic as well as heterolytic. The term itself it is telling homo means what? Two means what? In that chain, if it is having all the carbon in that chain, all carbon atoms are same, we will call it as what? Homolytic organic compounds. We will call it as what? Homolytic organic compounds. For this, I'll give one example. Very simple example. See here, all carbon atoms are same only. CH, C is there, C is there, C is there. All corners are having the carbon atoms. That's why it is homolytic. Then what do you mean by heterolytic? Instead of carbon atom, if it is any other atom is present like oxygen, sulfur, okay. So I'll give an example. So it is example for what? Heterolytic. How can you call it as heterolytic? Here also CH2 is there, CH2, 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 but it must have the carbon here. Instead of carbon, what we are having? We are having the oxygen. Okay. So this compound is as called as uran. Called as what? Uran. Okay. So next I'll give one more compound. That is thiophene. So instead of carbon atom, we are having the sulfur. Okay. Instead of carbon atom, so that's why it is called as what? Heterolytic organic compound. That chain, instead of carbon atom, if any other element is present, then we are going to call it as what? Heterolytic. This one furan, this one thiophene. Okay, thiophene. Next, homolytic. That homolytic, again there are two classified. They are classified as an alicyclic as well as aromatic. Alicyclic means what? Continuous chain. It must have okay continuous chain. Like a simple example, I'll go for alicyclic. CH2, CH2, again here CH2. Correct? Is example for what? Alicyclic. CH2, CH2, CH2. Next one. One more example I'll give. CH2, 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 again CH2. Okay. So this one is also what? Alicyclic only. The chain is what? Continuous with same carbon atom. Same carbon atom. Because the term itself it is telling homolytic. Homolytic is what? The chain is having the same carbon atoms with repeating. So here CH2, CH2, CH2 as well as CH2. So I'll give one more example. So if this one is cyclopropane because three carbon atoms are there. There is cyclobutane because four carbon atoms are there. Next, I'll give one more example. CH2, CH2, CH2. Now, what it is now. Example for aromatic. That is the best example is benzene. Best example is what? Benzene. Can you call it as benzene? No. If you write like this, again it is alicyclic. what? Polycyclic. But what we want? We want aromatic. Aromatic, what is the condition? The compound must be cyclic as well as it must have the double, single, double, single, double. Is it? See here, cyclic is containing double bond, single bond, double bond, single bond, double bond, single bond. So these are known as what? Aromatic compounds. Is it okay? You just copied all these things. Second I am saying organic compounds classified into open chain, closed chain. Open chain, those are straight chain as well as branch chain. Closed chain, they are having homolytic as well as heterolytic. Homolytic means what? They are having same carbon atoms. Heterolytic means the term itself it is telling. Hetero means what? Different. So instead of carbon atom, there any if any other element if it is present, that we are going to call it as what? Heterolytic. Then polycyclic as well as aromatic. Polycyclic, I give one two example. That one is CH2, CH2, CH2. This one is what? Cyclopropane, cyclobutane. Aromatic,